In today's lesson, we'll be learning how to determine the length of a line segment. Here's a summary of all the important pieces of information you need to know for this lesson. When you have 2 points, you can figure out the distance between these 2 points with this formula. This formula is based on the Pythagorean theorem, which you've learned in grade 9. In our first example, we want to find the length of the line segment GH. Since we've been given the coordinates of 2 points, we have enough information to find the length of this line segment. The first thing we want to do is write down our equation. I'm going to write a subscript of GH beside the D just so that I know what I'm figuring out. We now have a bunch of variables that we need to replace with numbers. Again, let's take a closer look at the coordinates we've been given. G and H, which is 4, 3, and 2, negative 2. That is going to be x1 and y1, and this is going to be x2 and y2. After I've labeled those two coordinates, I'm going to substitute those values into my equation. When I substitute in values, I like to put them in brackets. You don't have to, but that is what I like to do. Once we've substituted in our values, I want to clean up my brackets and signs. Once I've cleaned up my brackets and signs, I can go ahead and simplify some of these numbers. We're going to square both of these numbers right now. And we're going to simplify everything that's under the square root. So the length of line segment GH turns out to be the square root of 29. You can leave your final answer as a square root, unless it's specified that you need to express your answer with a certain amount of decimal places. I'm going to go ahead and simplify the square root of 29. If you throw that into your calculator, you're going to get a number. I'm going to round it to the nearest tenth, which would make it 5.4, and since there are no units specified, you can just say 5.4 units. And I'm going to put a box around my final answer. Therefore, the length of line segment GH is actually 5.4 units. In our second example, we've been given the triangle DEF. We've also been given the coordinates of all 3 vertices, as you can see here. We want to classify triangle DEF either as equilateral, isosceles, or scalene. Before we start this question, let's review what these 3 terms mean. Equilateral means all 3 sides are equal. All 3 sides are equal. When you have an isosceles triangle, only 2 sides are equal. Only 2 sides are equal. And when you talk about a scalene triangle, all 3 sides are unequal, meaning they're all different. Therefore, our strategy is to figure out the length of each side of this triangle and see which situation it fits. Let's go ahead and start figuring out the lengths of each of these sides. I'm going to start with the length of ED. To make life easier for yourself, I would highly suggest you label the coordinates of both E and D. And I'm going to show you what I mean in 1 second. Just like I showed you in the previous example, I'm going to label this x1, y1, and I'm going to label this x2, y2. That makes life a little bit more easy when I am substituting in my known values. So again, the first step you want to do is write down your equation. Again, you'll notice that I'm using a subscript of ED just so that I can differentiate all the different calculations I'll be doing. As I've mentioned in the previous example, I like to put my numbers in brackets when I substitute them in. You don't have to do the same, but that's just a habit I've learned. At this point, we want to clean up some of our brackets and some of our signs. So let's go ahead and do that. I'm going to simplify whatever's in the brackets. Now I'm going to square the numbers that are within the brackets. At this point, I'm just going to simplify whatever is under the square root. You're going to get 100, and you should know that the square root of 100 is 10, and I'm going to call this 10 units. At this point, we're going to use the exact same method for the other two sides. So let's organize ourselves a little bit. So I'm going to write length of DF. I'm going to write down the points. D is -8, -4. F is 4 and -6. Again, you can label these coordinates as x1 and y1, x2 and y2. You're going to take these coordinates and substitute it into the equation we just used. I'm not going to show you the work because it's pretty tedious, and I think most of you know how to do this. So we're going to end up with an answer of D. I'm going to put a subscript of D and F is going to be equal to the square root of 148. Again, if you want, you can simplify that to 12.2 units. For our third side, we're going to do the exact same method. So again, let's organize ourselves a little bit. Let's write down length of EF. Let's write out our coordinates. E is -2, 4. F is 4 and -6. Let's label our coordinates x1, y1, x2, y2. Again, I'm not going to show you the work because it's pretty tedious, and you can do this on your own. Therefore, the distance between points E and F is going to be equal to the square root of 136. You can simplify this if you want, and I'm going to simplify this to 11.7 units. I'm going to zoom out and show you all the work that was required for this one question. Therefore, the length of all three sides are 10 units, 12.2 units, and 11.7 units. If you refer back to our original strategy, you'll remember that when all three sides are unequal, when they are different, that means we have a scalene triangle. So let's write a concluding statement. Since the sides are different lengths, therefore triangle DEF is scalene. If you haven't seen these symbols before, that means since, and that means therefore. In the second part of our second example, we want to find the length of the median from E to DF. A median will cut another line segment in half. So let's make a point on this diagram to indicate where that's going to be roughly. I'm going to estimate it to be there roughly. I'm going to call this new point G. And if you recall, you can indicate that DG and GF are equal in length with a line like so. And I'm just going to draw a dotted line to show you what we're trying to figure out. So we want to figure out the length of that dotted line. Before we begin this question, let's figure out a strategy. If you take a look at point G, it is in the middle of line segment D and F. If a point is in the middle of something, it is called a midpoint, which means you're going to be using the midpoint equation that you learned in a previous lesson. And since we want to find the length of a line segment, we're going to be using the equation we just learned today. To figure out the midpoint of line segment DF, you need the coordinates of both D and F, which we have been already given. So I'm going to write that down. D is -8 and -4, while F is 4 and -6. If you recall, the equation for midpoint is like so. Midpoint is equal to x1 plus x2 over 2 and y1 plus y2 divided by 2. As I've done in previous questions, a good idea might be to label your coordinates. So I'm going to call this x1, y1, I'll call this x2, y2. I'm going to show you the very first step in this. We're going to substitute in our known values. So I'm just going to draw a little arrow to show you that I'm moving it over here. So I'm going to have -8 plus 4 divided by 2. And I'm going to have -4 plus -6 over 2 over here. If you do the work for this question on your own, you would end up with a final answer of -2 and -5. So let's go back to our diagram and double check to see if this is somewhat reasonable. And as you can see, the point G, which is a midpoint of line segment DF, looks somewhere around -2 and -5. Now that we have the coordinates of our midpoint, which we've named G, all we need to do now is take the coordinate of E and G and plug that into the equation we just learned today, which is length of a line segment. I'm going to show you some of the work for that. So let's go over here. The 2 points that we're looking at are E, which is -2 and 4, and our midpoint, which I've named G, and that is -2 and -5. Like I've mentioned before, you want to go ahead and label these coordinates to make life a little bit easier for yourself. I'm going to call that x1, I'm going to call that y1, I'm going to call that x2, and I'm going to call that y2. I'm going to do the first few steps of this calculation. So we want to figure out the distance between these 2 points, E and G. You're going to use the equation that we've been using pretty extensively for the last couple examples. At this point, all you need to do is substitute in your values. So let's go ahead and do that. I'm going to have -2 subtract -2, and I'm going to have -5 subtract 4. You can go ahead and do those steps on your own, and eventually you should end up with the square root of 81. And if I were to simplify that, you would get 9 units. Let's go ahead and see all the work that we did for this one question. Let's write a concluding statement. I'm going to write, therefore, the length of the median is 9 units. In our last example, we want to find the area of a right angle triangle. There are two pieces of information which are very important. If you recall, the formula for area of a triangle is base times height over 2. As well, a right angle triangle looks like this. That would be the height, and that would be the base. Therefore, we want to find the side lengths of the height and the base. We do not want to find the side length of the hypotenuse, because that would not be useful to us. Using the coordinates that were given, let's first do a rough sketch of this triangle. Let's go ahead and take a closer look at this Cartesian plane. As you can see, the y-axis and the x-axis are already labeled. However, the triangle has not been drawn. And the axis has not been labeled, but you can assume each of these lines is 1 unit. Let's go ahead and do the first coordinate, which is -3 and -1. That would be right over here. So I'm going to label that A, that is -3, -1. Now let's label our second point of B, which is 0 and -3. So that's going to be point B, 0, -3, and our final point of C is 4 and 3. Right over here. So let's label that 4 and 3. I'm going to connect the dots. Just by looking at this diagram, you should notice that the 90-degree angle is probably located at point B. However, if you weren't entirely sure, you can go ahead and find the slopes of each of these lines. I'm going to do that over here. The slope of AC turns out to be 4/7. The slope of BC turns out to be 3/2, whereas the slope of AB turns out to be -2/3. Since the slopes of AB and BC are negative reciprocals, that means these two lines are perpendicular, which means they meet at a 90-degree angle. Again, I'm not going to show you all the steps for figuring out the lengths of AB and CB, but I'm going to kind of set it up so that you know what the general strategy is. So let's write that over here on the side. So I'm going to write length of CB. So go ahead and write those coordinates in to help yourself out. C is 4 and 3, and B is 0 and -3. Again, you want to label these so that you can easily substitute these numbers into your equation. Once you put that into your equation, you should get a value of the square root of 52. And if you simplify that, you should get 7.21 roughly. I'm going to do the same thing for the other line segments. So I'm going to write the length of AB. So I'm going to write down my coordinates for A and B. So that is -3 and -1. The coordinates of B is 0 and -3. Again, I'm going to label these coordinates x1 and y1, x2 and y2. That makes life a little bit easier when I substitute in these values. Once you put it into your length of a line segment equation, you should end up with the square root of 13, which turns out to be 3.61. If you refer back to the diagram we just made, AB would be considered the base, while CB would be considered the height. So let's make a little note of that for ourselves. I'm going to say that is the height. And I'm going to say that is the base of the right angle triangle. Once we've done that, we can easily substitute those values into the area of a triangle, which is base times height over 2. So let's just substitute in those numbers, 3.61 and 7.21 over 2. You can go ahead and just plug that into your calculator. I'm going to do that right now. 3.61 times 7.21 divided by 2, which will give you approximately 13.0 if we're using one decimal place. And I'm going to say units squared since we're talking about area. I'm going to put a red box around my final answer. So again, I'm going to zoom out to show you all the work that was required for this one question, and I'm going to sum it up with a concluding statement. Therefore, the area of triangle ABC is approximately 13 units squared. You'll notice that I'm showing less and less work in each example, and the reason for that is the actual calculations. You can do that by yourself, but the strategy is what is most important, how to attack each question. And that's what I'm trying to teach you in these later and more difficult examples.